So in order to do that, we have to represent space in terms of grid cells. And this is done by means of a grid spacing that we call delta x. Okay, and so we have these grid cells, and they're all the same size. And we have a pointer that we call the k in this example, which is the grid index, which tells you which grid cell we're talking about. 1, 2, 3, 4, and so this is how we organize space. And with this definition, we can actually now express spatial gradients using three different options we have. We can use a forward difference, which is now expressed here on the right hand side. So let's see how it's defined. Forward difference is just the functional value in the grid box called k plus 1, which means to the right. Okay, minus the value in your grid cell, and then divided by delta x grid space. You have a backward difference, which is with k minus 1, or you have a center difference. Okay, and f is the value, is the variable that you're interested in. It can be horizontal velocity, or it can be the sea level. Okay, so this is how you can now express spatial differences, and we already talked about how you do it with temporal differences, with a time step and a time level. We already talked about that before in a previous lecture. Okay, so this is what we call a grid index and a grid spacing.